In the annals of human history, certain events stand as inexplicable enigmas that continue to captivate and perplex generations. One such event is the Tunguska event, an otherworldly phenomenon that unfolded on the Siberian landscape over a century ago. Welcome to this documentary that delves deep into the mysteries of the Tunguska event, a powerful explosion that unleashed devastation on an unimaginable scale, leaving behind questions that continue to baffle scientists and intrigue enthusiasts to this day. The Tunguska event marked a significant moment in Earth's history when a colossal explosion, equivalent to approximately 12 megatons of energy, shook the remote landscapes of the Yeniseisk Governorate in Russia on the fateful morning of June 30th, 1908. This explosion, which unfolded near the Podkamennaya Tunguska River, sent shockwaves through both the sparsely populated East Siberian taiga and the scientific community at large. The explosion's aftermath was nothing short of astonishing. Approximately 80 million trees spanning an area of 2,150 square kilometers were laid flat, leaving a haunting impression on the landscape. Eyewitnesses, though few in number due to the area's remoteness, indicated that at least 3 individuals may have lost their lives in the wake of the event. This event is primarily attributed to the atmospheric explosion of a stony asteroid, believed to be around 50 to 60 meters in size. This asteroid, moving at a relatively high speed of about 27 kilometers per second, approached from the east-southeast. Despite being classified as an impact event, the object responsible for the Tunguska event is believed to have disintegrated at an altitude of 5 to 10 kilometers above the Earth's surface, without making direct contact with the ground. This lack of an impact crater differentiates the Tunguska event from typical impact events. The sheer magnitude of this explosion could have obliterated a large metropolitan area, underscoring the devastating potential of such cosmic occurrences. On that fateful June 30th, 1908, at approximately 7:17 local time, witnesses, a mix of Evenki natives and Russian settlers, observed an astonishing phenomenon. A bluish light, comparable in brightness to the sun, traversed the sky, leaving a thin trail in its wake. As it neared the horizon, a brilliant flash illuminated the scene, creating a billowing cloud followed by a pillar of fire casting a reddish hue across the landscape. This pillar eventually split into 2 before fading to black. Roughly 10 minutes later, a sound reminiscent of artillery fire reverberated through the air. Those nearer to the explosion's source noted that the sound appeared to shift from the east to the north. The explosive sounds were accompanied by a shockwave that literally knocked people off their feet and shattered windows hundreds of kilometers away. The event's impact reverberated across the world, registering on seismic stations throughout Eurasia. The shockwave's force approached that of an earthquake measuring 5.0 on the Richter magnitude scale in certain locations. Night skies in both Asia and Europe took on an unusual glow. Reports from Sweden and Scotland documented photographs taken at midnight that showed surprising brightness, even without the use of flashbulbs. This sustained luminosity was attributed to light passing through high-altitude ice particles that had formed due to the explosion's extremely low temperatures. Decades later, a similar phenomenon was replicated by space shuttles. The aftermath of the Tunguska event included a noteworthy decrease in atmospheric transparency in the United States. More than 10 years after the incident, a scientific examination of the region took place, due in part to the area's isolation and the significant political upheaval in Russia during the 1910s. In 1921, Leonid Kulik, a Russian mineralogist, led an expedition to the Podkamennaya Tunguska River basin under the auspices of the Soviet Academy of Sciences. Even though they did not reach the epicenter of the explosion, Kulik and his team were spurred by local accounts to believe that a massive meteorite impact had caused the explosion. Consequently, Kulik secured funding for a subsequent expedition to the suspected impact zone. In 1927, Kulik's scientific expedition headed to the Tunguska blast site. They enlisted local hunters to guide them to the heart of the blast area, hoping to discover an impact crater. To their astonishment, no such crater existed at ground zero. Instead, they encountered a region spanning roughly 8 kilometers, where trees stood scorched and devoid of branches, but still upright. Trees further away from the center displayed signs of partial scorching and had been knocked down in a pattern radiating outward. In the 1960s, it was determined that the flattened forest area covered approximately 2,150 square kilometers. Upon closer examination, Kulik identified what he initially believed to be meteorite holes, though he lacked the means at that time to excavate them. Over the following decade, 3 more expeditions ventured into the region. Kulik discovered a series of small pothole bogs, each measuring 10 to 50 meters in diameter, which he speculated might be meteoric craters. After considerable effort, Kulik and his team drained one of these bogs known as Suslov's crater, only to find an old tree stump at the bottom, dispelling the notion of a meteoric crater. In 1938, Kulik arranged for an aerial photographic survey covering the central portion of the leveled forest, but the original negatives were destroyed in 1975. Positive prints were saved for study in Tomsk, Russia. Expeditions during the 1950s and 1960s identified microscopic silicate and magnetite spheres in soil samples from the area. Comparable spheres were hypothesized to exist in fallen trees, though they remained undetectable using contemporary methods. Subsequent expeditions did locate such spheres in tree resin. Chemical analysis indicated these spheres contained higher nickel-to-iron ratios, consistent with meteorites, and were likely of extraterrestrial origin. The sphere's distribution in the soil aligned with expectations for debris from a meteoroid airburst. Additional studies demonstrated unusual metal ratios in the spheres relative to their surroundings, further supporting their extraterrestrial source. Analysis of peat bogs in the area also revealed anomalies consistent with an impact event, including abnormal isotopic signatures of carbon, hydrogen, and nitrogen. These isotopic ratios did not match those of adjacent layers and were absent from bogs outside the area. In 2013, researchers published results from an analysis of microsamples taken from a peat bog near the blast's center. These fragments displayed characteristics indicating potential extraterrestrial origin. The leading scientific explanation attributes the explosion to a meteor airburst above the Earth's surface. Meteoroids entering the atmosphere at speeds of 11 kilometers per second generate immense heat due to air compression, often burning up or exploding before impact. Since the 20th century, monitoring Earth's atmosphere using infrasound and satellites has revealed that asteroid airbursts comparable in energy to nuclear weapons occur regularly. Events like Tunguska, with energies of 5 to 15 megatons, are rare. Close examination of the explosion's effects on trees suggests the meteor approached at an angle of about 30 degrees from the ground and 115 degrees from north, exploding mid-air. Amidst prevailing beliefs attributing the event to an asteroid or comet, alternative theories suggesting natural gas release or geophysical mechanisms persist. The Tunguska event's enduring mystery fuels ongoing scientific discourse. From its enigmatic origins to its impact on science and culture, it serves as a reminder of cosmic forces shaping our world. As the skies guard secrets, Tunguska's timeless enigma beckons us to explore the universe's depths, connecting the cosmos with our planet's history.